Here we're going to graph the equation by putting points. We're going to plot the points, and to do this we're going to plug stuff into our equation to see what the result is. So because this is set equal to y, we're going to plug something in for x. Usually whatever's by itself, you want to plug in for the other variable. So in this case, we're going to plug in, and again, this is an equation. We don't know whether it's a function or not. We haven't really even talked about that yet, and we hopefully will shortly. But for now, we know that we have this x, we can plug in some numbers. So I'm going to start with what I think might be the smallest x I could plug in. I know that I cannot take the square root of a negative number. So I'm going to plug in -3. Because that would give me square root of -3 plus 3. And that's going to equal, well, -3 plus 3 is 0. The square root of 0 is 0, so 0. So that equals 0. And I'm going to write that as an ordered pair, -3, comma 0. And then I'm going to say, okay, let me plug in -2. What happens when I plug in -2? Square root of -2 plus 3. Well, that's going to be the square root of 1, which is equal to 1. So -2 is 1. Now let's check some stuff. What happens? I'm going to do this over here. If I plug in -4, -4 plus 3, and we're looking at the square root of each. Well, that's going to give me the square root of -1, which is not a real number. So we couldn't plot it on this graph. It would not be able to plot on this grid. So because we can't graph it on our grid, because this is in the real numbers, we won't plug in -4 or any value that would give us a negative. We also don't want to just plug in stuff that gives us, like if I plugged in -1 plus 3, this is going to give me something. It's going to give me the square root of 2. The problem is that doesn't come out, right? That I can't pull that out. That isn't out as a solid, easy to work with number. Can I approximate it? Absolutely. Are we going to? No. We're going to try to work smarter. We're going to try to think these through. So we did 1 and we got this. So let's try plugging 1 in. Let's plug in 1. This would be the square root of 1 plus 3, which is going to equal the square root of 4, which is equal to 2. So I put out 2. So at 1, I'm at 2. This is totally giving us a place to go. Now we're going to think a little bigger than that, right? We want to get a little bit higher. How far do we need to go? Because if I plot these at -3, 1, 2, 3, I'm at 0. At -2, 1, 2, I'm at 1. And then at 1, I'm at 2. So then let's see how much bigger we could go. I want to come out to a number I can pull out. So I'm going to plug in 6. Let's plug in 6. And I know 6 is off our chart, but it's just off our chart, so it gives us something to work with. 6 plus 3, the square root of 6 plus 3 is equal to the square root of 9, which is equal to 3. So then we have 6 and 3. So just outside here, I would be up here. But this is usually enough. We usually don't need to graph every one of these lines. You usually need, it depends on the problem, but 3 is a good number. When we get into rational numbers, you kind of need to know where your asymptotes are, and then we'll talk about getting 2 on the left, 2 on the right. But we still don't need to graph everything. So in this case, we can map this, and this kind of goes like this. We can draw this graph. And it goes on forever. It's going to gradually get bigger, but kind of slowly. And that's the graph of this square root function, this radical function here. Right there, that's a radical. This symbol is called a radical, and this is a radical function. So there's our example. I hope this helped.